Welcome to Study Loop.
We need to find the sag of this cable from point A to point B due to the maximum allowed tension of 400 pounds on this cable. So we're essentially trying to find what this value of H is here whenever there is a tension of 400 pounds on this cable. And we're given that the weight per unit length of the cable is 2 pounds per feet. And we can also find the length from point B to point C in the x direction by using the given length of 160, dividing it by 2, and getting a length of 80 feet. So we're going to start this problem by we're going to find what this length is here, y of b, and we can use that value to help us solve for the value of h. So to find y of b, we can use the equation that y of b is going to be equal to the tension divided by the weight per unit length. And we're given by the problem. The problem gives us the tension and also the weight per unit length. So we can write y of b is equal to 400 divided by 2, and this will give us a length of 200 feet. And we're now going to find what the length of this c is, this constant c. So we can write, now that we know what y of b is, we can write that y of b is equal to c times the hyperbolic cosine of x from b to c divided by c. And we know what y of b is, and we know what x of bc is. So we can plug in those known terms and solve for the unknown value of c. So we plug in y of b, and then we plug in x of bc, and we take this equation, solve it for c, and we'll get a value of 31.6 feet. So we know what c is, and we know what h is. Or I'm sorry, so we know what c is and we know what y of b is. So to get this value of h, we can take y of b, subtract c, and that will give us the value of h. So the height h, the sag, is going to be equal to y of b minus c, which we can write as h is equal to 200 minus 31.6, and this will give us a sag of 168.4 feet.